Hello and welcome to this presentation on IBM Cloud Pak for MultiCloud Management. My name is Gayatri Ranganathan and I'm a Technical Offering Manager. This is the high-level architectural view of the Cloud Pak for MultiCloud Management. Today I will be talking to you mainly about the VM infrastructure management capabilities within the Cloud Pak for MultiCloud Management. This presentation will be divided into three sections. In the first section, I will be talking about the various infrastructure automation capabilities catering to the IT operator persona. In the second section, you will see the various self-service capabilities that we are bringing into the Cloud Pak that will enable developers to have self-service infrastructure provisioning capabilities. And finally, I will talk about the various value adds that the Cloud Pak for MultiCloud Management brings to our existing Cloud Forms and Cloud Automation Manager users. So let's get started. Todd is our IT operations persona. He has several requirements to enable him to perform his everyday tasks efficiently. For instance, he wants to know how he can get visibility across the entire hybrid IT infrastructure from a single control point. He wants to know if he can deploy hybrid workloads across Kubernetes clusters and VMs from the same place. He also has to monitor the security and the compliance posture of the entire hybrid infrastructure. And finally, he needs automation capabilities to reduce toil and drive operational efficiency. Cloud Pak for MultiCloud Management has a rich set of capabilities to deliver complete end-to-end infrastructure management functions, including automation for the most common tasks. First, we have Cloud Forms, which is the downstream version of the open source project ManageIQ. Cloud Forms provides discovery of existing VMs, provisioning of new VMs, inventory and lifecycle management of new and discovered VMs, compliance and policy management of VMs, and various other automation capabilities. We also have Terraform-based automation capabilities that lets Todd provision infrastructure via Terraform templates, providing him with infrastructure as code and promoting a full GitOps process flow. And Ansible provides the core automation capabilities like executing playbooks for VM provisioning and also executing remediation actions for any policy violations. As you can see, Cloud Pak for MultiCloud Management has a rich set of capabilities for your entire infrastructure management. Now let's see a demo to see some of these infrastructure management capabilities within the Cloud Pak for MultiCloud Management. Welcome to this demo of IBM Cloud Pak for MultiCloud Management. Today I will be showing you a demo of the infrastructure management capabilities within the Cloud Pak. On the main overview page of the Cloud Pak, you get to see the different cloud providers where the infrastructure has been provisioned like Amazon, Azure, IBM Cloud, OpenShift. You can also see how many of these compute resources are provisioned as Kubernetes clusters versus VMs, and also the different containerized applications and VM services. You can also see details on the cloud infrastructure by provider type, the region where these resources exist, as well as the purpose, which simply mean the labels and the tags on the clusters and VMs respectively. We can also see the compliance posture of our entire hybrid infrastructure to see if any of the clusters or VMs are violating compliance standards. Now let's dig deep to see how the infrastructure management capabilities are enabled in the Cloud Pak for MultiCloud Management. Cloud Pak for MultiCloud Management leverages Cloud Forms for its infrastructure management capabilities. On the main Cloud Forms dashboard, you can see a lot of interesting information about the physical and virtual infrastructure that are being managed by this deployment of Cloud Forms. How does Cloud Forms get all this data? CloudForms uses different providers to connect and manage to different clouds and infrastructures. There are cloud providers like Amazon EC2, Azure and OpenStack, as well as infrastructure providers for different hypervisors. Here we see the various cloud providers that are created to connect to various public clouds. You can also add a new cloud provider to bring a different environment under management. Let's choose one of the existing cloud providers and drill into the details. As you can see, there is a lot of information that CloudForms is able to discover for this cloud instance, such as the number of images, VM instances, the different availability zones that they are spread across, and much more. CloudForms performs a process called Smart State Analysis to do deep introspection of VMs and hosts, which enables it to do discovery in an agentless way. Being agentless means that the analysis can be performed even on VMs that are powered on. We can also provision new VM instances into this cloud infrastructure by simply choosing one of the supported images and provisioning a new instance. This will take us through the whole request and approval flow, and then the VM will be provisioned and added to the CloudForms inventory. My request is in pending state, waiting for approval. Once it is approved, it will go through the whole process of provisioning the infrastructure. As you can see, my VM has now been provisioned. Let us go and take a look at this newly provisioned VM. I search for my VM instance by name in the list of provisioned instances, and there it is. This new instance has been added to the CloudForms database, and now CloudForms is able to infer all the relevant information about this VM instance. From here, we can see details like monitoring information, perform lifecycle actions like retiring this VM, and also add compliance policies to this instance. Now let's try to check the compliance posture of this VM based on that policy that just checks whether this VM has been powered on. As you can see, it is compliant. We can also do other configuration actions like perform smart state analysis, change the tags, or remove this instance from the inventory so CloudForms is no longer managing it. For now, I am just going to turn the power off to save on some resources. While my VM is powering off, let's explore other capabilities of CloudForms. For instance, you can add a provider for your infrastructure to manage your data center resources such as your VMware estate or your Red Hat virtualization platform. We can also create policy profiles for compliance checking, which we can then apply to VM instances and templates. Here I'm going to be creating a simple policy profile that simply disallows smart state analysis to be run on certain VMs based on a tag. Now let's go back and locate the VM instance that we had recently provisioned and apply this new policy to that VM. We can once again check for the compliance posture and we will find that this VM is no longer compliant. We can look at the history of how the compliance checks were executed. I have decided that I no longer want to keep this VM instance in the database, so I'm going to remove this instance from the CloudForms inventory database. And that's it. This VM has been removed from the database and it's no longer being managed by CloudForms. So in this demo, you saw how CloudForms enables the discovery of existing VMs, helps with provisioning new VMs, manages the inventory and the lifecycle for new and discovered VMs, as well as allows compliance and policy management. Thank you for watching. Now let's talk about some of the self-service capabilities that we are bringing to the Cloud Pak for multi-cloud management. Why do developers need self-service capabilities? Oftentimes, development teams are constrained by the dependency on IT ops to provision infrastructure so that they can push their code. By having self-service infrastructure provisioning capabilities, developers can push code to production with velocity and less friction. In order for Todd from IT Ops to enable self-service to the developers, he needs the right set of capabilities. He needs a UI-driven way with features like drag and drop to compose his services. He also needs a simple and efficient way to compose complex service flows that might include VM provisioning, cluster provisioning, and maybe even deploying an application onto these provisioned clusters and VMs. And finally, he needs a library where he can push these deployable services such that Jane and her team can make use of them. In order for Jane, the developer, to take advantage of the self-service capabilities, she needs to be able to see the list of services available for her team to use. She also needs to see a list of services that her team has already provisioned. Having such a self-service capability is sure to increase the speed and velocity of developers to push code to production. In the upcoming release of Cloud Pak for multi-cloud management, we are introducing this notion of a deployable service library as the consumption model for self-service. From the main menu, you can launch into the deployable services option, which will take you into this library view which will show all the services that are ready for you to use. In the upcoming version of Cloud Pak for multi-cloud management, we are introducing the concept of a deployable service library, which is the new consumption console for self-service. From the main menu, you launch into the deployable service view, which will show you a list of available services that are ready for consumption. Todd, the IT operations person, creates services to provision infrastructure based on templates, playbooks, Helm charts, etc. He can optionally compose applications using app definitions as part of the service flow. He may choose to test these services, and once he is satisfied that the services are functioning as per his requirements, he will publish these services into the deployable services library and assign them to users based on their role-based access control. From a UI perspective, when Todd wants to provision a new service, he can click on the Create Service button, which will take him into this canvas where he can drag and drop from the palette of available components such as Helm charts, Terraform templates, Ansible automation playbooks, and much more. He can drag and drop and provision this whole service flow. And once he's ready to publish them, he can click on the Publish button, which will put this newly composed service onto the deployable service library. Todd can choose to make this newly composed service globally accessible, or he can make it specific to a particular department based on a namespace. If Todd wants to also provision an application into this flow, he can create a new application, enter the app YAML, and then he can save it so that it shows up along the list of available applications. So you can see how easy it is for Todd to create and publish new services and add them to the deployable service library. Jane, the developer, can see the services in the service library under different categories. From this, she chooses to provision services. She can spin up clusters, VMs, and also deploy applications from the service library. She can also see a list of provisioned services in her account. So when Jane logs in, she is able to see all these services that are available for her team to use. She can select one of these services, enter all the required parameters, and then she can deploy the service. She can also see the instances view that shows us the list of services that are already provisioned. So with this UI flow, both Jane and Todd have an easy way to compose services and as well as to deploy services. As I have pointed out in the course of this presentation, we are integrating some standalone products into our Cloud Pak. These standalone products will no longer be available as individual products, but rather only as part of our Cloud Pak. I wanted to highlight the key value add that Cloud Pak for multi-cloud management can bring to this existing customer base. For CloudForms, we have already seen the rich set of VM management capabilities that CloudForms brings to the Cloud Pak. However, Cloud Pak for multi-cloud management also brings a lot of extra value for the existing CloudForms customers. For instance, Cloud Pak for multi-cloud management with its Kubernetes cluster management capabilities can provide a single view across entire hybrid IT infrastructure spanning Kubernetes clusters and VMs. It also adds a lot of automation capabilities via Ansible and Terraform, including day 2 operations around monitoring and problem remediation. Cloud Pak for multi-cloud management has a notion of a hybrid application model, which can include components that are containerized as well as running on traditional VMs. For these applications, Cloud Pak for multi-cloud management can do the entire lifecycle management, including providing real-time app metrics, application placement and scheduling, as well as eventing and automation. And finally, with the rich set of compliance and governance capabilities in the Cloud Pak for multi-cloud management, we are sure to enhance the policy management capabilities that CloudForms provides and bring a whole hybrid point of view to the entire governance capabilities. We also provide automated vulnerability and mutation scanning. Similarly, for existing customers who use the Cloud Automation Manager for Terraform-based provisioning of VMs, CloudForms can provide additional value by means of discovery of these provisioned VMs, doing the entire inventory and lifecycle management of these provisioned VMs. We can also apply and monitor compliance policies to these VMs through Terraform, and then we can do chargeback and quota management for these VMs as well. This capability is just for VM management. We have already seen that Cloud Pak for multi-cloud management can also bring the whole hybrid point of view for these customers as well. So you can see how Cloud Pak for multi-cloud management is able to deliver a lot of added value for these existing customer base. Let's see a quick demo of how a VM provisioned through Terraform can be easily discovered and managed by CloudForms and Cloud Pak for multi-cloud management. Hello, in this demo, I will demonstrate the value that Cloud Pak for MultiCloud Management brings to our Terraform users. We start with the overview page of the Cloud Pak. Here we see a list of containers and VM-based resources. Let's focus on our VM resources. You see that we have 293 VMs on Amazon, out of which one is non-compliant. Let's provision a new VM using the Terraform automation capability within the Cloud Pak for MultiCloud Management. First, I check to ensure that I have a valid cloud connection to the Amazon region I want to provision. Then I search the existing templates and pick a simple template that provisions a single VM on Amazon. I enter all the relevant data, pick the right cloud connection, and enter all the required information and deploy my template. You can monitor the progress of this deployment in the logs. After a few minutes, my instance has been provisioned on AWS. Now I go back to my Cloud Pak for MultiCloud Management menu and I launch into CloudForms. CloudForms can do discovery of deployed VMs in the environments that it has connections to via providers. Here, this Amazon connection is connected to the same Amazon region that I provisioned my VM using Terraform. So if I search that, you will see that CloudForms has already discovered my VM and retrieved all the relevant data. Not only does CloudForms do discovery and inventory management, we can also use it to do other actions like check for the compliance posture. This VM has not been checked for compliance, so I'm going to apply a simple compliance policy that simply checks whether a VM is powered on. So I apply this compliance policy, and then I check the compliance for this VM. After a few seconds, you will see that it has been flagged as compliant. Now let's try and fail the compliance by powering the VM off. Now when we check the compliance for this VM, after a few moments, you will see that it has been flagged as non-compliant. Now let's go back to the Cloud Pak for MultiCloud Management console to see if this new VM and its compliance status is reflected back in the Cloud Pak overview page. Now you can see that there are 294 VMs, of which 292 are compliant. That means 2 are non-compliant. Let's further drill down and go to our governance and risk dashboard and try to see what more further details we can find about it. If you go into the virtual machine compliance policies and search for our virtual machine, you will see that it is showing in that list as non-compliant. From here, you can you can dive into the policies, or you can launch out into CloudForms once again and go to the appropriate policy that has been applied to this particular VM. Cloud Pak for MultiCloud Management brings a lot of value to our Terraform users, including discovery, inventory management, lifecycle management, and compliance and policy management. In a future video, I will be showcasing the chargeback and quota management capabilities. Thank you for watching. I hope with this presentation you were able to see the extensive infrastructure management capabilities that Cloud Pak for MultiCloud Management has to offer. Thank you for watching.